And welcome back. As we go ahead and continue our review, today let's go ahead and dive into a quick recap on interfaces and inner classes. So the first thing we need to recall with interfaces is that interfaces are simply just structures that Java uses to dictate what are the methods that a class needs to have. For example, if an interface has the methods getName, getAge, then of course the class should have the methods getName and getAge. Now it doesn't mean that you're restricted to using those methods. You can create other ones. But you can kind of think again as an interface as like a template, saying like these things need to be here for this class. Now, if we want to use an interface, the class merely has to implement that interface. So let's just say we have public class ordered hourly employee, extends hourly employee, implements ordered. So you can see here we have a derived class of a derived class, and it's implementing this interface called ordered. Now, interfaces themselves can be extended by derived interfaces. So, for example, just like we have a derived class, we can have a derived interface. So, public interface showably ordered extends ordered. Now, the other thing that we had talked about were inner classes. Now, inner classes, of course, are classes that exist inside of another class. And because they're inside of another class, there are different ways that we can kind of handle them. While they're often used as kind of like a helping class. In this case, they're always marked as private, but they're not always done that way. Sometimes they're a full functioning class, but again, most of the time they're helping classes. However we look at it, if we have an inner class, the compiler, when we go to run it, is going to generate the appropriate number of class files for each inner class plus the outer class. So for example, if I have two inner classes, then I'm going to have 3 class files, 2 for the inner classes and 1 for the outer. Now, inner classes can also be marked as static using the static modifier. So just like we can have a static class or a static method, we can do the same thing with inner. Now, we can have public non-static inner classes, and we can also have public static inner classes. So with these classes, there's really kind of 2 different implementations here. All right, let's first look at the non-static one. So let's just say I have a public class bank account, and they have an inner class called public class money. So if we want to fully implement this in a program, let's say we have a bank account equals new bank account. So this is creating the bank account object in our main class. Then I say bank account dot money amount equals account dot new money $41.99. This is on a print line amount dot get amount. If we look at this breakdown here, bank account, of course, is my outer class. Money is the inner class. So we have to do outer class dot inner class, and then we name that object. But then in order to create a instance of the object, we have to say account dot new, all right, because we have to say the outer class object name dot new, and then of course whatever it is, money $41.99. And of course then we print it, you notice this is amount, so that is of course of the money class now, dot get amount. So if we actually run this program, we would get a value of $41.99. So it is a little bit tricky sometimes, making sure you get these in the right orders. So always, if you can't remember, go ahead and go back and look at an example here. But the biggest thing you have to remember, outer dot inner is generally the way these are going to go. Just like here, we have outer dot new and then inner. Now what about the static side of things? All right, that was the non-static. But what about static? Because static is going to behave just a little differently. If here is an example, I have public class, outer class, public static class, inner class, public void, non-static method, public static void, static method. All right, so we have, of course, here a static class, and you can see inside of it there's void and static methods. But how do we actually implement this? Well, if I have an object of the class, let's say we have outer class dot inner class, inner object equals new outer class dot inner class. Notice this invocation here, right here on this side, is different than how it was handled with the non-static class. So that is going to be our biggest difference right off the bat, is that our invocation is different because it's going right to new outer class dot inner class. We didn't have to do, like, for example, the outer class object created first, then name that one dot new. Now the advantage of having this one is when we go to invoke our methods, you can see we have, again, a little bit different way of doing this. Inner object dot non-static method, non-static method right here, inner object dot static method, or we can still go back to using outer class dot inner class dot static method. All these, of course, are valid ways of being able to handle inner class objects. And if we pop over to Eclipse, I went ahead and created an animal interface here, and we have, of course, some methods here that exist. And if we want to see how these work here, I went ahead and created a class called Interface Demo, and I'm implementing the animal interface. Now notice I do have a red arrow here, and I purposely left that in here because I wanted you to see how that's going to work here in a second. But first I want to point to our inner class here. We have a private class mammal, and I just went ahead and created a couple booleans here and a boolean method inside of that class. And notice this is a non-static class, so if we were to implement this, we'd have to use it with the non-static approach. But with our interface, if I want to fix this, you can see it was telling me to add the unimplemented methods. So I'm going to go ahead and do that. And you can see that these methods now all exist here within my program. Now I'm not going to go ahead and code all these here today because I'm pretty sure like most of these you can do, but I'm just going to go ahead and just do a few of them real quick. So let's just say the animal sound one is simply just going to return a print line statement with whatever animal sound that you're going to put in here. Now this, of course, could be handled with a string in here. So for example, we have a string called sound. But if I do it this way, it's because now it's not overriding what we have here. So this one doesn't have a string in it. But now if I put that here, you can see that that matches. All right. So it's very important that if we are implementing from the interface that we make sure that these method headers match the method headers that we have over here. And of course, if we wanted to see our mammal object in place here, we would have to probably first create our interface demo dot mammal. And you can see it shows up as a invocation option here. So I can do dot mammal, and let's just go ahead and say like dog equals, and we can't just say new dog because if you notice, we don't have a static class up here. Now I could fix that. I could easily come up here and just add static to this modifier here. And then I could just say we have a new dog object here. So interface demo dot mammal. There we go. And of course now we've created that object there. Now if I didn't have the static, honestly, I would have to first create a interface demo object, and then I'd have to create my mammal object. So there are advantages of having a static modifier here versus not, but sometimes we don't want that static modifier there. Sometimes we want it to be non-static. But that should give you a quick overview with using interfaces and with using an inner class. And we only have one more review topic to dive into, which is probably one of the heaviest, which is that of recursion.